Welcome back to Science Corner. This is where we really get into the science shaping things for all you curious listeners out there.
Great to be here.
Today, we're doing a deep dive into something pretty fascinating, sitting right at the intersection of, well, advanced AI and gaming. It's called Voyager.
Ah, yes. Voyager, the lifelong learning agent in Minecraft.
Exactly. And Minecraft, well, many of you know it, is this huge open sandbox world.
Incredibly dynamic. You can build, explore, create almost anything. So putting an AI in there that doesn't just do things, but actually learns,
Yeah,
that's a big deal.
it really is. So let's break it down. What is Voyager, fundamentally?
Well, at its core, Voyager is an AI agent, an embodied agent, operating inside the game Minecraft.
Okay.
But the key differentiator, the really interesting part, is its capability for lifelong learning.
Lifelong learning, so it keeps getting smarter.
Precisely. Unlike a lot of AI that you program for very specific tasks, Voyager can continuously pick up new skills, gain new knowledge, all on its own. It doesn't need someone to hand code every single new thing it might encounter.
Wow. Okay, so it's not just following a script. It's adapting, evolving almost within the game. That sounds like a major step.
It is a significant one.
Where did this Voyager project come from? And, if people listening want to dig deeper, where should they look?
Yeah, it's definitely generated buzz in the AI research world. The best place to start is their website, voyagerminddojo.org.
VoyagerInMondojo.org. Got it.
There you'll find a good overview, links to the actual research paper on ARX5.
Yeah.
That's where the really technical details are, and even the code itself on GitHub.
Open source.
Yes, which is great for the community. And an interesting side note, the website's design.
Mhm.
It seems inspired by other big AI projects like NerFi's, CLI Port, Vima.
Oh, interesting. So it suggests it's kind of building on or connected to that whole wave of current AI research.
That seems to be the implication. Yeah, it fits within that modern context.
Okay, makes sense. So let's get into the mechanics then. How does it do it? How does Voyager actually achieve this continuous learning? What are the key parts?
Right, the architecture. It's quite clever, really. It's made up of a few core components working together. First off, you have the action agent.
Action agent. Okay.
Think of this as Voyager's brain, its decision-making core. It uses large language models, LLMs, the powerful AI that are so good with text.
Like GPT-4 and similar models?
Exactly like those. This action agent uses an iterative prompting mechanism. Basically, it figures out what to do next by looking at a constant stream of feedback.
Feedback like what?
Well, things like the actual code it tried to use before, any errors that popped up when it ran that code in Minecraft, and even the chat logs from its interactions in the game.
So it's learning from its mistakes, literally. It tries something, sees the result, good or bad, and adjusts.
Exactly. It's very much like trial and error, which is, how humans often learn complex skills.
Yeah,
But it's constantly refining its approach based on those concrete outcomes.
that makes intuitive sense. What else is part of this learning setup?
Okay, another absolutely critical piece is the skill manager.
Skill manager, like a memory bank.
Sort of, yeah. It's Voyager's personal library of abilities it's already learned. And these skills aren't just abstract concepts. They're stored as actual executable JavaScript code.
JavaScript. So it's generating code to perform actions in Minecraft.
Precisely. This allows Voyager to reuse skills it's mastered and build more complex behaviors on top of them. If you look at the project's documentation, there's a skill library directory. It's organized into different trials, and inside those you find specific skills.
Can you give examples?
Sure. Things like collect bamboo or collect 5 cactus blocks, cook pork chops, even craft bucket.
Yeah.
Specific achievable tasks within Minecraft.
Right.
And each skill has its JS code file and also a .txt file that describes in plain English what the code is supposed to do.
That's neat. So it's got this organized library of code snippets it can pull from, very systematic. But what tells it what new skills to learn? Does it just wander around randomly?
Ah, good question. Now that's where the curriculum agent comes in.
Curriculum agent. Sounds like a teacher.
That's a great analogy, actually. It is like an automated teacher. Its job is to autonomously set new goals, new challenges for Voyager. It looks at what Voyager can already do and proposes new, slightly harder tasks to encourage exploration and skill development.
So it's constantly pushing Voyager to learn more.
Exactly. It drives the learning process forward. And then there's one more key piece, the critic agent.
The critic. Okay, what does that do? Self-correction.
Yes, essentially self-verification. After Voyager attempts a task set by the curriculum agent, the critic agent looks at the outcome in the Minecraft world. Did the bamboo get collected? Was the bucket crafted? And determines if the task was actually completed successfully.
I see. So putting it all together, curriculum agent sets a goal, action agent tries to achieve it, maybe using skills from the skill manager, critic checks if it worked, and all that feedback goes back into the loop to improve future actions and maybe generate new skills for the manager.
You've got it. It's a really tightly integrated, continuous learning cycle.
That's genuinely impressive. Okay, let's shift gears slightly. How does this actually work on a technical level? How does Voyager get into Minecraft and interact with the game world? What does someone need if they wanted to try this?
Right, the practical side. You definitely need a specific setup. First, you need Python and Node.js installed on your machine, the usual suspects for this kind of project.
Okay, standard developer tools.
Yep. And the project's GitHub page has instructions. You clone the repository, run pip install to get the necessary Python libraries. Pretty standard setup there.
And the game itself.
Of course, you need Minecraft, but not just any version. You have to set up a specific instance of the game, make sure cheats are enabled.
Cheats enabled. Why is that?
It likely gives the agent more flexibility and control within the game environment for learning purposes.
Yeah.
Less likely to get stuck on trivial things, perhaps. You also need to start it as a LAN world, a local network game.
Okay. Are there other technical bits?
Yes, quite a few specifics. Voyager relies heavily on what are called fabric mods. These are modifications to Minecraft that add functionality.
Mods, right, like custom add-ons.
Exactly. Things like complete config, multi-server pause, better respawn. These mods are crucial tools that essentially let the AI see and act within the game more effectively. There's actually a specific file, fabricmodsinstall.md, that guides you through installing and setting these up.
So it's not quite plug and play.
Definitely not. There are details, like needing Java runtime environment version 17 or higher just to build one of the mods, better respawn. And there's mention of specific configurations needed, even Azure login details like a client ID and secret value, suggesting maybe some cloud integration or authentication layer was used in their experiments.
Oh, interesting.
And they specify the exact Minecraft version they used, Fabric Loader-Haro.14.18, 1.19. So reproducibility requires matching that setup pretty closely.
It sounds like a very precise environment is needed to make it all work reliably. Okay, one thing I'm wondering. Can you actually watch Voyager, see what it sees, like a first-person view?
That's a really good question. And the answer is, sort of, but not directly in real time easily. There are some limitations with the underlying library they use, MindFlayer, which interfaces with Minecraft. It makes getting that real-time first-person stream tricky.
Ah, okay. So how did they make those demo videos you see on the website?
They used a clever workaround, the replay mod for Minecraft. So they let Voyager run, recording everything it does over potentially long periods. Then they use the replay mod to essentially play back that recording and render the video from Voyager's perspective.
Ah, smart. A post-processing solution to visualize it. Okay. You mentioned the skill library earlier. Can we dive a bit deeper into what those skills actually look like? What's the code doing?
Sure. So as we said, it's organized into trials, then skill directories with JavaScript files and text descriptions.
Yeah.
Let's take collect bamboo.js as an example.
Okay.
The code would likely instruct Voyager to first make sure it's holding the right tool, maybe an iron sword or axe. Then it would use a function, probably something like explore until, to find bamboo plants in the vicinity.
Right.
Once it finds one, it uses another function to break the bamboo blocks, maybe mine block. And finally, it needs to navigate to the dropped bamboo items and collect them. So, a sequence of actions defined in code.
I see. And another example, maybe the cactus one.
Collect 5 cactusblocks.js. Similar idea. Equip the right tool, maybe an iron pickaxe this time, though you can break cactus by hand. But let's assume it learned a tool is better. Then use the mindBlock function repeatedly, targeting cactus blocks until it's collected 5 of them. It might also involve searching if cactus isn't immediately visible.
So each skill is like a little program for a specific Minecraft task. It's literally learning to code its own actions.
That's a perfect way to put it. It's building its own library of functions to operate in the world. And it gets even more interesting.
How so?
Within that skill library, you also find directories like control primitives and control primitives context.
Primitives, like basic building blocks.
Exactly. These seem to contain fundamental, maybe even pre-programmed or very early learned basic actions. Things like mindblock.js, craftitem.js, placeitem.js, exploreuntil.js, which we mentioned, and even killmob.js for fighting monsters.
Ah, so the more complex skills like collecting bamboo might actually call upon these lower-level primitives.
That seems very likely. It provides a foundation.
Huh.
Voyager can then combine these basic primitives in novel ways to create and learn those more sophisticated skills we discussed earlier. It's a hierarchical approach to skill building.
That makes a lot of sense from a learning perspective. Build up complexity. Okay, so connecting back to the name, lifelong learning agent. How does it actually achieve that lifelong aspect? Does it remember things between sessions?
Yes, persistence is built in. When you start Voyager using the Python script, there's an option, resume.
True. Okay.
If you set that, Voyager will load its state, its learning skills, its progress from a previous run.
Yeah.
So it can literally pick up where it left off in its learning journey.
So it doesn't have to start from scratch every time.
Correct. And you can also specifically tell Voyager to run for a particular task using a skill library it has already developed. This really highlights the cumulative nature of its learning. The knowledge sticks around and becomes a resource for the future.
It really is engineered for continuous growth and adaptation then. It feels like more than just, a clever game bot. It feels like a real step towards, well, more generally adaptable AI.
I absolutely agree. Voyager, with this whole setup, the action agent using LLMs, the skill manager, the curriculum agent pushing it, the critic agent checking it, it really represents a significant advance in creating AI that can handle open-ended learning in complex, dynamic places like Minecraft.
This has been incredibly illuminating, really getting into the weeds of how Voyager works. It's clear this isn't just a game project, it's pushing AI research forward. As we wrap up, what's a final thought you want to leave our listeners with on this, something to chew on?
Well, think about this. Voyager learns and adapts in Minecraft, which is, incredibly rich and complex and open-ended. If an AI can achieve this kind of lifelong learning there, what does that mean for other complex areas?
Like real-world applications.
Exactly. Could you see similar AI systems tackling challenges in robotics where environments are constantly changing? Or maybe in education, adapting to individual student needs? Or even accelerating scientific discovery by exploring complex data or simulations? Could systems that learn continuously like Voyager fundamentally change how we approach AI development and how we interact with intelligent systems in, well, almost any complex domain, virtual or real?
That's a powerful question. The potential seems huge, if a bit daunting too. It definitely gives us a lot to think about for the future of AI. Thank you so much for breaking this down for us.
My pleasure. It's truly fascinating work.
And thank you all for joining us on Science Corner. We'll be back soon with another deep dive.